We have another USB door.
Oh, this one?
Yes. You have
You got it there?
the pointer also. You have a light on this? Yes, I'm going to share the screen, but I cannot understand. This is in French. Hello, everybody. I appreciate a lot those that survive until now to be here. I will be very sad if I am alone in this room. So glad that you are here. Indeed, I had done a plan for this presentation last week, and watching the discussion, I changed everything. My idea is to take one project and detail a little bit about ontology engineering, what do you have developed and how do you have developed it. But I realized that plenty of people for me indeed are still thinking, why do I need to use ontology? And then I changed this for several use of ontology in different projects in the last years. I go through the first, so my agenda is like this. I go through the all projects quickly, just to give you some examples of use of major ontology, and then I will detail a little bit the digital twin project that we are developing nowadays, and one project in reservoir evaluation in petroleum exploration, okay? So that's the idea. I try to not give a lot of information for you, but perhaps I cannot avoid. So do a panic face if you think that I am doing something long. So I introduce myself. I am Mara. Of course, that I take a picture with in 15 years old because I'm not stupid. But I am a geologist, graduated in geology, and I have done master degree and PhD in computer science. Master degree, it was a Petrobras collaboration project that I brought myself, and PhD, it was an application that I will show you both in an exploration. So I am a full professor in the Informatics Institute of Universidade Federal do Rio Grande do Sul. In the end, I will do a test. One of the questions is for you to repeat that. the name of the university. I am the leader of the research group in computer systems for petroleum exploration and production in this university. I have indeed a very large experience, like those in large projects in ontology development and knowledge engineering and things like this. In petroleum areas, some of them out of is in medical, health, public system, and so on. But my main focus is really petroleum. I am a black woman, okay? So my several contacts is there. If you Google Marabel, I'm sure that you'll find. Okay. I first try to understand in this room what kind of profile do you have. So I will ask you to raise your hand if you know the meaning of these three concepts. One person? Two persons?
All three or
no, I will not ask you to give me the meaning of the concept. But have you heard before? Have you used it? Oh, it's getting better. Okay. Yeah, one is okay. One is okay. Because one is more Guarino thing, the second is more Barry Smith thing, the third one is more philosophy things. It's just to understand where you are. Okay. For you, that picture is nice. It was during a strike in Porto Alegre, full of people in the street complaining about everything, and then someone write down this in the front of a big journal that we have there, and I have no idea why, but it's fantastic. I could not avoid of using it. So it was my PhD student that took the picture indeed. So for you, ontology is, I tried 4 definitions, informal definitions. I'm not so ontologist like this. Who think that is a terminological set modeling in O? Raise your hands. It's not a test, don't worry, because I will not give a grade to you. 1, okay. A knowledge model about subdomain. Okay. A logical theory that studies the meaning of a formal vocabulary. 2, okay. You are raising all the time. It's not fair. Okay, and then an explicit description of concepts related to a problem or a domain. So we don't agree even with the concept about ontology. Well, I think that ontology is this. Ontology is a logical theory that's based on philosophy that we use to produce models, and models that make explicit the meaning of a formal vocabulary. That's the original definition of ontology in computer science area. I'm not saying that the other definitions are wrong. I say that this is the more precise use of it, because sometimes we collapse the ontology artifact, the whole file, with the approach that we use to model ontology, okay, to create this knowledge artifact. But of course, every ontology is a knowledge model. And of course, that every ontology is about some domain and so on. So it's nothing wrong, but I am just evaluating the background that you have to not to fly away in the way that you cannot understand. Okay, I will stop with classes about ontology, and I will tell a little bit about what we are doing using ontology. We are doing these all things. We are doing expert system, very classic expert system. You take a problem, you took the knowledge of the expert, we take the part of ontology, because knowledge models and ontology are different things. But I will avoid this philosophical discussion, computer science plus philosophical discussion right now. But we developed expert system. We develop the reasoning of this expert system. We materialize in a piece of software and you put in the company to solve real problems in daily basis in industry, okay? We develop a lot of domain ontology for general uses, and I will show some of the uses later on. So it's more this kind of collecting vocabulary, defining, discussing with people if we adopt this or that, and that's it. We do a lot of legacy database integration using ontology because it's a huge problem for everybody nowadays, the island of information problem. We do also indexing and searching over unstructured data, lots of documents in lots of computers and repositories and so on, and people are crazy to recover and to find information that they need, and we develop ontology for doing that. We do some visualization tools that use ontology to show the data in a more human way, and we do machine learning, training machine learning algorithms, putting some knowledge inside. So a lot of applications for ontology. I will show you some of these projects, okay? So why petroleum industry? They are paying me for 30 years to solve problems on this. In the beginning, the name was not ontology, it's knowledge base, it's semantic, and so on. But nowadays, it's clear. They contract me to build ontology. Okay, and also because I am a good project manager, you know, they're experienced, so they give me some weird projects to develop because they know that I will deliver something. But it's a scientific, very advanced industry. They explore, they stand the state of art because they have very hard problems. They have a lot of money to solve the problems. So it's good for academic people to work with them because the problems are interesting in the scientific view. They are evolving, at least in Brazil, Petrobras and the other partners, are evolving to a fully industry 4.0, which means a full digitalization. That word is terrible, but you can do it. Okay, so they are trying really to have everything automatized and registered in computers and so on. They request a lot of knowledge intensive applications, then we need to model the knowledge for them. But the main problem is that they have a lot of software providers, which are old in the industry. They have their own very good software that are the basis for exploration and production. And these owners, these providers of this software, don't want to open the file model of them, or the data models, or the conceptual model of the application, because they get a lot of money translating one model to other, evolving the model from one version to other. That's the main business of these guys that are providers. So there is a strong revolution in the petroleum industry, the guys that produce the oil, to get out of this model and have some standards for interoperability. So interoperability is really a problem. I will define interoperability here. For me, maybe you have a different concept, but we are ontologists, so you should define the concepts. Interoperability is the capability of exchange data between applications. Okay, it's not integrating data. Is that my idea is to export a file from one application, software application, and that file could be read by another application, keep the meaning of the entity that are used in the system. That's the idea of interoperability, okay? And this is a strong problem and a lot of effort doing to this. We have a big research group working in this project, and they probably have a lot of lessons to teach to any other industry because the problem is really big there. Okay, and then they have this kind of technical niches. I don't know how to say this too, which means I have engineering, petroleum engineering, reservoir engineering. I have the people that deals with business. I have geologists, and they need to talk to each other in order to make the oil go out of the well. So it's a real communication problems also. I believe that you identify yourself in several of these projects, these problems, because we are seeing this during this presentation today. Okay, so main problem is this. You have activities like this. I have a geologist, I have the seismic guy that is doing interpretation, I have the engineering that keeps with the well, and then these activities are supported by applications. The applications, the database of the conceptual model, the data model reflects the view of these people. Sometimes more than one, but each application materialize a view of some of these technical guys, okay? Then you have the software that deals with these models. So I have the human feed of these models, and then I have the software that manipulate the model, and my problem is that I want that they software talk each other and send information to the other software to process. That's the simple problem. And then when they are using one application, it's okay, but when we are getting to get more application, we have this problem that we want to have all these applications together under a uniform view. And that is the main role of ontology. Okay, I believe that you identify this also in a scenario that you work with. Okay, so ontology is the central, solve all the problems, but there's a lot of problems in this scenario. So I am saying in this scenario, there is a lot of problem that's not an ontological problem. We have problems about translating software, about platforms of computers, about many other things. And the central cannot deal with the other problems. So we need to be aware that ontology is not the central. I should not say that because I got money when you think that ontology serves for everything, but it's not the real thing. So cannot solve everything, but can help a lot in several types of problems. That's why it became so important to talk about using ontology on software. The ontology theory, mainly the ontology theory, independent in the way that you materialize your ontology artifact, helps in several types of problems. For example, when I use to talking about realistic ontology, talking about material entity, because I am keeping simple, okay? When I have some material entity, and this material entity, I can identify that is what we call in ontology a rigid entity. I can have these to anchor models from one each other, and then to change the qualities of these objects between models and use this to keep a track of the information. So it's a basic approach that we use to do some integration and interoperability of software. And then with this, I can do indexing and searching, data integration, locally at least. Interoperability means bridges between the island of information, according to Chris. Supervised training in machine learning, and so on. Okay. So that's the general approach. I use the philosophical basis to analyze the domain, to do ontological analysis over the domain. I found the entities that are presenting all the domain with kind of rigid behavior. I mean, it keeps the identity along of the domain, even if it's being affected or not by the process. And then I can use this entity to provide a uniform view, a more small model that can be used as a reference model. So that's the main approach about ontology. That's why understanding the theory is important. Then when you recognize this entity, then you define the dependent entity, qualities, the relations, and blah, blah, and so on, measures and things like this. Okay? Then it's not working anymore, but So I will show you some projects. It's okay for now? Everybody is with me? Nobody is sleeping? Good. Okay, first I will let you know about some old project probably you have heard about. That's my thesis result, Petroledge. We define a large ontology for reservoir characterization, which is used to define the quality of the rock as a reservoir, the potential capability of storing petroleum inside. Okay, I had a very good geologist that used to be employee at Petrobras in diagenesis analysis and things like this, and we developed this crazy ontology with more than 2,000 terms, and use this to describe reservoir instead of a textual description. That is what most of the companies in that time used to do. Today, this software is, I can say that is the main software for this task in the world. Most of companies use that or use their own proper database system and software to do that. Okay, but there is not other product good as mine. Sorry to say that, but that's a kind of standard in the industry to do that. One interesting thing, if you are more interested, there is this paper about. One interesting thing is that I have 2,000 vocabulary defined, formally defined here, but I have only 3 entities. Crazy. The rest of the vocabulary is used to qualify this entity. One of the entities is sample of rock. The other entities is the constitution, the grain that form the rock. And the other entity is the mineral that constitute this grain. I have only these 3 top-level entities, and then the rest is relationships, is technical vocabulary to describe qualities and blah, blah, and so on. Okay, dependent entity, using the BFO terminology. So it's what I say to you is that when you say, oh, ontology is too complex, no, it's the opposite. You get a very mass domain and you look at this with your ontological glasses and you pick 1, 2, 3, 4, 10 entities. And these 10 entities will support you through all the development, all the process of production in your company and so far and so on. Okay, so that's the big advantage of using this approach. So we support them to do some very detailed diagenetic characterization, means the evolution of the rock and so on. We do some automatic interpretation of the depositional environment, the diagenetic environment, and we use the vocabulary to index the pictures that they take from the microscope, thousands of pictures that they take from the microscope, they describe using the controlled vocabulary, and then they can search, index, and do a lot of this. And the funny thing is that this controlled vocabulary, I produce reports, textual reports, quite similar for the handmade reports that they used to use before. Then they click in a button, it exports a report, and then put along with the technical report of them, like they were produced by a person. So it's a very nice product. To develop this product, I tried to sell this project to Petrobras from the beginning, and they said, no, that kind of ontology, space shuttle, and things like this, we don't put money on that. And then we developed this project using public money. And then the public money, I don't need to say, that's very few. Then we create a company, because in Brazil we have a special funding for entrepreneurship and so on. And then with this funding, we develop the product to a final version. And the funny thing is that this week we are negotiating the intellectual proper transfer of this product to Petrobras finally, because for all this year they are paying me to use as a service provider. Not to me, to the company. I am a kind of partner of the company, but That's the end of this story. In the end, they realized that's much cheaper to pay me the projects and have myself like I am a permanent consulting of Petrobras, at least in 15, maybe 20 years from now. Okay, that's the happy story of Petroled, Rock Viewer, and okay, I am index pictures and have this kind of text that's produced by the system. And we use this to do that. I mean, this is a project of a master student, but Petrobras uses this to apply machine learning, to extract patterns and so on of this data, because then they have a quantified data about several qualities, you know, that's the main advantage. Okay, just quick. Then we have quite the same in another scale of collection of information from rock, which the StrataLedge software is using for some, not so many companies like the Petroledge, but is using for companies in South America that produce oil. Okay. Then if you want, we have this paper that describe the main approach of using this, developing these ontologies, okay? The project of a master guy. This is a more recent project, is paid by Petrobras. I comment with some of you before. That is for the problem about the mountain of information. Okay, what time I need to finish? Someone take note when you start, because I don't. Okay, you keep talking forever.
It goes around 5:30.
5:30, we start 5:30, so I have 15 minutes.
Let's do a little bit less. We'll have time for questions. Let's say we have 8 minutes.
Okay, do like this when I need to finish, okay? So this project is a Petrobras project. It was contracted. The problem is that they have lots of unstructured information, documents, spreadsheets, pictures, image, things like this, draws, maps, that they are crazy to recover in a search, you know, it's a mess. And you know, we don't have very good commercial tools to do that. So what we have done, we take the ontologies that we had done before, and then we develop new ontologies doing what? We collect the main documents, the more important documents of the company, which are technical reports that they need to deliver to the federal agency, petroleum agency, okay? It's large documents, it's technical report. We use some machine learning extraction of the vocabulary, and then we take the ontologies and we define formally this vocabulary derived from BFO, I believe. Maybe UFO, this one, but I believe that is already BFO. Then we define this vocabulary. We take this vocabulary for people, technical people in Petrobras. We negotiate with them. We had a lot of fights and so on, but in the end, they agree or they get tired to discuss about some artifact. And then the artifact is used in a system that scan these documents in database, extract the OCR of the documents. Then there is another part of the project that extracts the OCR, find the words and do some measure about the sensibility of the word to the document and so on. If there are people from information retrieval, you know what I am talking about. It's not something so different in the state of art. And then we use this for searching the information. And then we develop a tool here that is to do annotation over the image. Because the problem is that the text, you have the word there, but the image, you don't have the word there. What Google does is to look for the word around the picture in the document. But if you have a seismic image, which is not inside of a report, you don't have that cloud of words around. Then what we do is to take some poor geologists and give them 10,000 pictures, maps, and figures in a mix of things, and they label them. So each one of the picture got 5 classification from the users. We do like a force task for 2 months, and we got like, I don't know, 30 poor geologists working with this, and then we produce this fantastic database for teaching machine learning for our algorithm. And then we apply machine learning. I don't know exactly what the kind of techniques that they have done, because I have very good people in machine learning too. And then index the information with very high percentage of correct classification. You know, it reflects, if I have few samples, it reflects that. How do I build this image database? Because of course that Petrobras has not give us the images, because it's part of their strategic and sensible problem. Then I took the geologists of my group, and we look in the internet, in magazine, in journals, in scientific paper, and you take a lot of collection, and we collect 10,000 figures like this. We put in a database, then they found that there is lacking some of the image. They give us some examples, and then they run the algorithm of machine learning inside of the company to get the rest. And then they are using this, it's called the busca semântica inside of Petrobras. It's a nice tool. The busca semântica itself, it was developed by Petrobras people, not by us. We just provided the machine learning algorithms, the indexing algorithms, the OCR extraction, and so on, and they put all of this together to use. I am lazy. I don't create a very good publication of this very interesting project, because I start another project just after that. But I have this publication on Montobras. It's open. It's open journal. If you are interested in this general approach that is explain what we have, but it doesn't cover the part of OCR and so on, information retrieval. Okay. Okay, then is the past. Then I will show you the ongoing projects. Some very interesting, exciting project. Some of you know already, Lua Garcia has finished the doctoral project a year ago. Is working in a project with us that is called Georeservoir project. Lua Garcia developed a medium-level ontology to describe objects in geology. So all this problem that we have in chemical area and substance area, like constitution, meteorology, and so on, we have been published in the last years. So if you look for his name, you will find a set of papers discussing this problem in modeling for this material domain. Not, of course, our examples are in geology, but the problem, ontological problem, is described in a more generic way. Okay, Lua is the one that has decided to move from UFO, which is the top level ontology that is created by Guizardi, a very friend of mine, to BFO, because BFO is more connected with material entities and so on, and UFO is good for business process and so on. And then he convinced me, and then his doctorate, and then he moved, and we are using BFO until now. It's not a religion. It's just a pragmatic choice, like you yourself used to say. For process, now we are going back to UFO, because BFO has very general concepts on process, and then we cannot model. Then we are going back to UFO. And sometimes you use Dolce, you use OntoClean. We have no problems about anything. We are academic, we have no compromise, we don't pay to use, so we are happy doing anything. So the whole set of developments after this project of Lua is being probably with Lua as a co-author. But what we are doing after that with this background provided by Lua is this developed, contracted by Petrobras? So what Petrobras has a problem. They need to describe a seismic session or an outcrop and define the relations of these bodies, and then to compare this deposit with other deposits that they have found around the world, someone that's just sedimentary deposit, not related with petroleum, to understand how is the spatial distribution of this body in subsurface. Because we cannot go down in 5,000 meters depth to see the distribution. Then we need to understand the distribution, and we use outcrops and seismic session to understand this distribution, and this is what this software that we are developing now intend to do, to support the 3D distribution of bodies of rock and compare in a database one each other to see if it's potentially similar to something that they have done. They call this analog deposit. Okay, then we have developed this wonderful ontology, which was done by Fernando Ciconeto. He's an Italian last name. Fernando is a master candidate, is already finished, and they have a set of papers describing this ontology. All these ontologies are free access, public. If you want, you can download from this GitHub thing. So the GeoReservoir provided by Luan. We have this about the spatial relations of material bodies. You can download, and feel free, if you have any problems, send a message to me, okay? So that's about geology. I have some couples of things going on, but I will move on to PET Twin project, which is the project on digital twin. Our intention is to really provide a framework, theoretical framework for digital twin that can fit, and then for the companies to use this to regulate the provider, the software provider, to understand when the software provider offer a product of software, where this software should fit in this diagram, okay? That's the general idea of the project, and some tools that we are developing with this. So you have, that's the Libra digital proposal. Libra is our partner in this project. Libra is the consortium of companies created to explore pre-salt in Brazil. So the idea of them is that to take all these data sets, to have these integrated through a uniform view, and then have this data analytic in these 4 separate types. Okay, is topside, subsea, well, reservoir. Okay, and then provide some insights, decision make, and so on in real time. We are working only with production, operation of the plant, not design and not plan. Okay. Okay, then ontology, of course, is the same route to solve everything. One interesting thing for you is that everything in that level is generic, shared, and open for access. Even if you want to develop a company using our visualization tools, of course, that's just prototype. You can use our ontology wherever you want, be free to use. And this part, that is the implementation inside Petrobras or Libra, Shell, and Equinor, which are the guys that are paying the bill, so it's confidential, because we are helping them to implement the solution inside. And we use the USDU has the repository for exchanging data, okay? So you have attended the Nicolau Santos presentation on Monday, explaining the ontology. And I'm using the ontology for this, and I will stop right now. Failure prediction, we are producing synthetic data for feeding machine learning algorithms. We are using to annotate the data that they receive from several different providers. we are using for monitoring production. I would show you a video of doing this, and of course we intend to do data analytics. We have not started this. This project is 4 years, almost a little bit less than 4 years. We are with 18 months from now. Okay, then. Okay, I would talk a little about ontology engineering, but I will skip. Our vision is that to have these tools, independent tools, running over database model, cloud, based on the ontology and stored in USEU, using the ontology for doing that. We are doing a strong effort. And more important is that we have these, I think that is interested to show you what we have been done. Is a lot of ontology for indexing figures, for deep marine deposits, so that part is the geology one, that part is the production plant, failure monitoring, production plants, and the extraction of information is the guy over there. Everyone, I had a student leading the development, and then I have this big group. We have some differential, like Regis Romeu is a retired reservoir engineering of Petrobras, very well known in Brazil, very experienced guy, and now he's my postdoc, which makes me very happy. Lucas Valadares also is a geologist of Petrobras, experienced geology. Givanildo Nascimento used to be the previous data management of the data reservoir area. So it's a very experienced guy inside of Petrobras. It's my PhD students. And the other guys are postdocs and the students that is full-time students by now. Okay, that makes a difference. That's it.
Thank you.
Okay, thank you so much, Mara. And then I will open for the stage for any question. Yes.
Just you have obviously a huge experience, and thanks for sharing that. And you have developed successful domain ontologies, over many years. And obviously, this has been discussion many times. What is your advice on doing that to avoid, everyone has a different view and you never agree on anything, and this, and to actually get to something that is has a lasting value.
Okay, I have many advice.
So
one that sounds weird for you is that don't think that ontology solves everything. Ontology is a small tool, very particular one that solves a set of problems, not so few, as you can see, but it's not the same ground, So I am a little worried nowadays because ontology became fashion. It's a buzzword, and everybody say, put ontology on there. What's ontology? As we show here, nobody's agree what is ontology. So don't get very high expectation about what's possible to do. Is a conceptual model like you had before when you work with data models. It's a conceptual model with more capability of capturing semantic. So it's a simple tool for solving some set of classes of problems. So that's the first. Second, top ontology is not the choice of a top ontology. It's not like you marry someone. It's not like to choose a religion. I became a Muslim from now, so I stopped drinking, no party anymore, and nothing to do. It's another tool. For communication, it's easy if the other side knows what's the dependent entity, what's the rigid entity, and you bring to them a vocabulary and ask to them. It's a process, it's an object. Because you have a technical vocabulary to have this kind of endless discussion, because it's endless discussion. It's awful. We need hours to have the proper definition, formal definition of a vocabulary, and then top ontology, any of them, helps a lot in doing that. It's not a religion. Don't feel like this. I don't use any kind of top ontology. Let Barry Smith, Nicola Guarino, and Chris, and so on, fight each other for, dominance and so on. But as we are, the rest of mortals, we are the people that want to use the tool. So sometimes it's good for something, sometimes it's not so good, just move it to the other. Don't do the same with your wife or husband, because it's a little bit more complicated. But with top ontology, no problem. They are not easily integrated. The word harmonization between top ontologies is something is a fake news. You cannot do that because they start with a different view from the beginning. Anything below occurrent and perdurant is not possible to integrate. I do this as an exercise with my student. I can tell you that's not possible to integrate. Then choose one and go ahead with this. Anyone is better than no one. I can tell you, when you say that I am not using any top ontology because I don't decide, I hear this, that you don't know how to develop an ontology and you are developing a crap team. Sorry to say that, but you asked me. So my advice is choose one, choose two, three, doesn't matter. Use someone because it will make your life very easy. And there is a lot of applications for ontology. It's very good to have one, but it's a lot of effort. So it's something indeed to be done in the academia, because we have students that work for free or for scholarships and so on. And you need a kind of small detailed task and so on. It's an awful task to be done. I love to do, but it's an awful task. It's not something that you do quickly. It's not in the time of the industry development. So be aware about this when you face a project like this. You can be disappointed how the effort in getting this. But after you getting this, you have plenty of happy software running using this inside of the company. It's used for regulation, for documentation, for supporting software, many things. It's very good result of an effort. So I think that's it.
Very moving words. Okay, any more questions?
We have the dinner also.
No, okay, so with that, we will conclude. We have one more presentation, which is very much related to Industrial Ontology Foundry, and Will Sobel will talk about some of the latest latest work happening in the technical principle of Industrial Ontology Foundry.
Okay. I am going to make this quick, take pity on everybody after sitting in our 35-degree rooms all day. I know everybody's dehydrated, I'm dehydrated, so I'll try to make this very fast. I'm the presumptive chair. I guess I am now the chair. This is actually an older deck. I am now the chair of the architecture task group. I should just admit it and get on with it. And figure out how to click this thing. That's the wrong button.
Yeah, I think you may be safer using this.
Okay. I need to be safe. Okay. Actually, I stole this from Farhad. He did a much better job. I just threw something together. I love this sort of, or, you know, the orbit of, you know, the solar system, DFO in the middle. Anyway, so we you should see his picture. It's much better than mine, and it's really good. I think you should actually put that on our website. It was brilliant. I loved it. So what we've been working on, the architecture task group, we originally started to go down the path of patterns, as I had talked about last time, but that didn't go too well. We had to go back to sort of square one, our foundation of what are we doing. So we started working on the IRI format, and we actually adopted it, but it's actually gone through a separate, another revision, which I'll talk about in a second. And we've started working on our development and release processes. There's actually a NIST project that's being funded right now to develop tooling around ontological development, which hopefully will not just be for IOF, you can actually use it for other ontologies as well. So there's gonna be development tools and patterns and other things that are gonna be associated with that. It's a whole or continuous development and integration, or continuous integration and deployment framework. And of course, we settled on BFO as our TLO, so yes, we have picked a TLO. But usually the way we do things is backwards. We don't, so we've kind of backed into our strategy. Instead of, you know, starting with a strategy and then figuring out how to do our IRIs and our annotations, we decided to actually go and do our IRIs and our annotations and figure out what our strategy is going to be, which is kind of an interesting process. Maybe it's working, I don't know. Anyway, it's interesting, but we're going to try to fix our horse later, but it seems pretty happy right now. So our structure and versioning. So we started out with sort of date versions. We've organized our ontologies by topics and subtopics. That stayed the same. We've changed our URL a little bit on Lisa's advice. We changed from Perl to Spec to align with some other ontologies that are out there. And we decided to go with a YYYYNN. But the number is now going to be a release number. That allows us to set our cadence and do a monotonically increasing version number as a numeric suffix for the year. We talked about it in the group, and this will allow us to have continuity between releases. So we know that, you know, 2 comes after 1 usually, and then 3, instead of like going maybe 4, 6, 12 or something like that, and then getting people confused. Unless we were able to settle on a prefixed cadence, but we weren't sure if we were able to, and we wanted to have some flexibility around that. So it's gonna look something like this. We're just gonna have these increasing numbers. That's new. Modularization, as we backed into our architecture after doing our IRIs, we came up with the concepts of topics and subtopics as being an organizational construct. We didn't start with the idea of having modules or topics and subtopics and then built our IRIs, but we built it out of that. Same thing with versioning and our release process and structure. We kind of backed into it with our IRI doc, but we started with a date stamp, we've moved to a number, we're going to be still sticking with some kind of a date type stamp. We still have to work on this, and this is something that we're going to be working on, and I'd like actually opinions on this, but how we're going to be able to synthesize the development versions with the release versions. So we have the pre-release versions that are going to be coming out. They need to have some kind of a version IRI so that we can have some kind of consistency between the various different pre-release versions that are working on future versions of the ontologies that are in flight, and then be able to link them up with the ones as they get released, as they go through the whole CI/CD process, and then get the final version stamp. So there's going to be some mechanics around that, and that still needs to be worked out. So, you know, we're definitely looking for more advice on people who have done such as this. And so we've basically inferenced out our architecture from that. So basically, also our naming conventions for both topics, subtopics, how we capitalize, how we name them, whether we have spaces or not, that's all part of the IRI doc, as well as our classes, the camel case, upper camel case for classes, lower camel case for object properties and data properties and so forth. And the naming conventions are all in this document. So that's our strategy around naming, and we're trying to really lock it in, or else we have complete chaos. So one advice, if you're developing an ontology, get this stuff done up front, which we did not. Make sure you have a good strategy lined up, because it's kind of step -1 to doing any ontological development. But we are now set, and people who are developing the working groups are aligned with it, which is a good thing. This is some examples of the naming convention. So basically, this is core. We have the new date stamps here, etc. So I'll jump through this quickly. I'm trying to get us all to dinner. The annotation doc is actually a new one that we just started working on almost 6 months ago, which is going to be a really quick little document. Going to take about a month, and as I said, 6 months. So right on time. We started coming up with, like, okay, we have all these annotations. We have the annotations, of course, have annotations. So we had an annotation vocabulary. All we wanted to do is just have some rules of the road for how do we do our annotations. Many months later, and a lot of discussion, turns out it's a little bit harder than we thought. But we do now have a set of rules, which actually I find really nice here, that you can follow when you're developing your domain ontologies to create a set of annotations that are going to be consistent across all of our working groups. And if you look at our working groups right now, and you look at the annotations, they were just chaos. And that's because we didn't have any clear guidance as to exactly what to put in them and how to do them. So, like, labels and titles, it's actually a bit harder than you think, to do, like, labeling of classes and properties and such. Are you going to use lowercase? Are you going to use spaces? Is it going to be the same as a local name, etc.? So we've normalized a lot of this on some of the ISO stuff. I have another slide on that in a second. And we've defined things like, natural language definitions. We've got rid of the elucidation, because people found that they couldn't quite figure out when to use elucidation, when to use natural language definition, and so forth. We came up with a whole bunch of rules. We have some new annotations like is primitive. And the reason we came up with some of these things is because we had to be very explicit for automation. So when we think about this, what we're trying to do is find a way to enable the continuous integration and validation technology, so that it can look at our annotation and say, okay, did you do this right or not? Even things like around our natural language definitions, we want them to be having a certain structure. So right now, like, our natural language definitions and our labels are structured around ISO definitions. ISO labels, lowercase, spaces between words. ISO 704 for all of our definitions. That means they cannot start with an article. They have to be substitutable. They have to have no punctuation. They have to, at the end, they have to have, they can't be circular, should not be circular. We finally caved in on, but they have to be targeted towards a domain expert, which means that the objective of our terminology in the ontologies is not to be read by an ontologist, but to be read by a domain expert. And that was key for the natural language definition. There was a bunch of discussion around that, but I think it means that we can now use our domain ontologies, not just as ontologies, but we can also use them as glossary and a common set of terms across multiple different domains, which is, I think, a nice added benefit of doing these exercises, because even if you don't have the full reasoning and logical models, at least you have a common, you've done the vocabulary work, which is a big piece of it. And we broke out FOL, definition, and axioms as two separate things for primitive and non-primitive, because some definitions have both necessary and sufficient conditions, whereas axioms either have necessary or sufficient. We can have a series of those. They can augment the FOL definition if you want to. You can add additional ones. We have now ways of pairing those up together, and a lot of consistency around the structure of those definitions. So how we're going to write them, they have to be written in first order logic. They have to adhere to, there's a paper attached to this thing which describes exactly how the syntax has to go, what letters, what symbols you need to use, all that kind of stuff. And then the semi-formal, which is what we're working on right now, is the last piece of this document to go. That was something I thought, oh, that'd be simple. Yeah, we just write, we just translate it into English. Well, guess what? Not easy. And when we started doing the translations, it turns out that nobody could agree, or there was a lot of different opinions. Jim Logan finally came up with some good examples of how to structure some of the language, and now I think we have some decent templates. I have to just tease out what our final decisions were, and Barry helped out with that too. So I mean, there's a lot of work to create some patterns so that you could take the FOL expressions and turn them into readable English, because it's a transitional, between your natural language definition, which is domain, to your FOL, which is purely ontologists. This is kind of helping people understand in language what that FOL expression actually means. So that's a big piece. I think we've done a pretty good job at actually creating some language around it so that even people like me can understand it. So I was pretty happy. So again, we back into the architecture here. We kind of, this is our strategy now. But we figured out how to, through creating this, these rules, how to use the annotations to drive some of our automation and create the strategy of how we're going to present a lot of this information and create the FOL. Now, the interesting thing about the FOL is also that, it can be interpreted, but we can even do multi-place logic in there. So it's not like the temporal relations and things along that line, which you can't do in DL. So the DL may be axiomatized a little bit less than the FOL expression. We can put more in the FOL expression than the axioms than we may be able to do in DL, in which case we want to actually be able to interpret this, the FOL expressions. I was talking to, I think it was Arco, or I think Arco about it, and maybe translate those into Cliff or some other language where we then can actually do some interesting additional work on them. So that's something that we're thinking about going into the future, but this at least opens that up for us, and now we've got the formalizations and the descriptions, and we've locked down all the requirements as a bunch of musts, because I'm a standards person, so I tend to write a lot of capital bold musts, just out of habit. So there's this project going on that NIST is funding that is going to build out a complete CI/CD framework for ontological development. This is going to go beyond just IOF, and we want to use it for other projects as well. The objective here is to create a set of automated, I think there are Jenkins processes, but I'm sure they have to be, Jenkins jobs that run whenever you create, if people don't get, if you create a pull request, basically what happens is that will automatically fire off. That will run a whole bunch of Sparkle queries against your test data sets. You must have test data sets. And it will also run the reasoner to make sure that everything is logically consistent. And this is obviously a goal, but we want to have 100% test coverage on all the different terms that we come up with, so that we have test data. You can validate that things are doing what they're supposed to do in the ontology before we release it. So this is maybe this is going to be a stretch goal, but I always like to put it in there with software projects I run, because if you don't, then people will just not do it. So we are going to also create a document release portal. I have a image from Bible in a few seconds. So the next thing that we're going to be working on also is our branching and merging strategy, all of our documentation around this release process. There's a serialization technology that FIBO has that's going to be brought into this project to be able to allow you to diff the ontologies. That's all going to be part of it. And we're also going to require review and acceptance of the ontology. So somebody has to review them. So you create the pull request, has to be pass your automated test, as well as you have, I think 5.0 has 2 reviewers. We can come up with a policy on that as well. And we need to do release dependency management. That's what I was talking about before, to be able to relate the in-dev, in-flight ontologies together as things are evolving in parallel. So there's some complications around that. And then we have the annotation validation. So that's going to be a set of rules that are going to run against the annotations themselves to make sure that, if you say, is primitive is false, then you must have a natural language, FOL definition, and you must have some form of natural language definition. If you say it's true, then you can get away with just axiomatizing. And again, we can do a lot of work to make sure that we can guide and validate that so that we can keep the release process clean. So that's where we're going with that. So a lot around automation and verification. This is basically the 5.0 process, where they have GitHub pull requests, Jenkins jobs kick off, that a bunch of Docker containers build the image, and then they run all these things, code reviews here to approve, and then they also use Jira. We're using Jira, so basically there's going to be this feedback loop between the code reviews and the Jenkins jobs to Jira that will generate issues and so forth. So there's all of this machinery that's going to be put in place to be able to support the development. And this is the portal that I was talking about before. So 5.0 has this portal. I know their EDM Council in this project is thinking about doing something similar to this to give us, a clean way of being able to present the documentation out there. The nice thing about this also, if you just hit it with something like Prodigy, it will download the OWL or Turtle or whatever you want. It does multi-format. There's a whole bunch of capabilities behind some of the infrastructure they have built around the 5.0 ontology, which we're going to be taking advantage of. So it's pretty cool. They have little pictures, where you can look at all the relations to all the other bits and pieces. So that's also going to be kicking in probably sometime over the next I think it's about a year or so that the project goes on. The next thing we want to go into is kind of refresh this activity that we had going on, or started having going on last year, and then we had to go and basically roll back to our items, -1 and 0, which are the IRIs and the annotations. So I put this on hold for a while, but basically the patterns and some of the tools that we were looking at, like Otter, Comedy, and a few others that were out there. I also wanted to talk to Arco about Ocean that he's coming up with, and basically we need to have a set of tools to generate individuals for testing, as well as being able to automate some of the process of even generating some of the classes and make things more domain expert friendly is really the goal of all of this. So generators for individuals, of course, development rules and validate before release, all this kind of stuff. So this piece here is really where we're trying to get to at the end of the day and this is a big problem actually in the ontological development, is you tend to get a lot of people who are either philosophers or academics, and not to dig at philosophers and academics, but it's nice also to be able to get and engage domain experts so that we can start to mine their knowledge and bring them into the fold. But often ontologists tend to sort of talk in the secret language that is a bit off-putting. Because you have to get over that hump of understanding all of, especially when you have the TLOs and things like that, which have their own, of course you have the TLAs, like the TLOs, and 3-letter acronyms that, if you don't sort of know the secret language and you don't know what things are called, you can quickly step on minds, and that's something that we need to work on. So so Melinda from the maintenance working group has some great ideas around small modular ontologies, which I really liked some of her approaches, and factoring them out. She's done, like, her maintenance ontology is 13 classes, and extremely extensible. So that concept I'm trying to figure out, from an architectural guidance standpoint, start looking at how we can start to factor things into these smaller ontologies, which we can then allow for some agile refactoring. So then we can take those ontologies and start to move common cross-domain or cross-cutting concerns back into core and elevate them up. So that's another area that we're managing revisions. So just, how do we get everything to flow together? So anyway, yeah, so we need patterns. With the other thing that I want, and I keep going back to the domain experts, the other thing that we need is resources. And this is actually something that goes across model-based standard development in general, because I do a couple of other standards which are model-based. You need a dedicated modeler. You need somebody who is a dedicated expert in this case, ontologies. You need ontologists and people who can, do the FOL, do the owlizing, and free up the domain experts to be domain experts, and then manage that interface. Because in the standards process, like with MT Connect, it's a model-based standard, but I can tell you that there's like 4 of us, maybe on a good day, 3 of us usually, who can do SysML modeling. And we take that entirely under our purview, and then everybody else just has to send in definitions and information, how they think the information kind of looks. It's like, give me a rough sketch and pen, and crayon, and, we'll sort out the details of how this is supposed to tie into the model. So I think there's some similar workflow that we have to consider in IOF to get the domain experts in there by offloading some of the ontological discussions to either a separate group or somehow, factoring that out. So that's something I think that, is a topic for a discussion coming up. So then we can, and then the architects can also do things like look at, one thing also about having sort of a central architect or modeler, as we do talked about in model-based enterprise and SME, is having, a group of modelers who also have the cross-domain or cross-working group vision and can figure out, how to refactor things into cross-cutting concerns. So that's another area. That's actually all I had, really. So, yeah, so that's kind of where we're going with this from my perspective as presumptive chair. But I think we're making good progress. We've got some, we made some decisions. We're moving forward. We've got core released, as Serm said this morning. I don't want to kind of rehash that. And we're starting to now get, I'd say, foundations laid for organization of the various different working groups so they can work together and produce something that looks like a consistent set of artifacts, not, a dozen different artifacts that, had 1,000 different authors. So still more work to do on that, but at least I think we're on a good path.
Okay, thank you, Will. Any question to Will? Any comments actually will be more appropriate.
I have a contribution.
Yeah.
Small one. So that's a fantastic work, and indeed, it's a lot of work that we need to do before getting to that stage. That's a large problem. It's a great contribution because it's very difficult for us to decide when you say that we develop an ontology and we use O, is like to say, I will develop a building and then you get these bricks, you know. A set of bricks, a pile of bricks is not a building. And then from the bricks to the building, we have this path that you have gone through. It's a fantastic contribution. Maybe now people are not aware how fantastic this contribution is. But my suggestion, my small contribution for you is that you include in that fields of description of the concept two new things. One is a kind of bibliographical or documentary reference where the terminology is being used. I mean, can be a paper, can be a report, something that is, I mean, the best is to be open access, because this helps a lot, mainly between domains, to understand a little of the context beyond the documentation that you have. And also that you keep the name of the guy that has defined it.
Yeah, so
There is a problem doing that, I know, but that helps also a lot, because
yeah, on the first one, we do have a whole set of annotations that are dealing with the source and attribution and all that kind of stuff. So I think we already have those built into it. I just didn't go into that too much because of time. But yeah, the second one, that's interesting. It's sometimes difficult with standards to do the attribution piece. And I get what you're saying. I mean, I put all the names of the people on this document because one of the guys who works for a large company asked me to, because he said if I don't put his name on there, then his company won't think his company was thinking he was wasting his time. Now at least he can show that he's got some output. So there's validity to what you're saying.
yes, and maybe some intellectual properties and so on, but you know, that helps a lot.
Yeah.
Because when you cross domains, but at least the documentation, you know, a document that use the terminology in the context that is being defined.
Yeah. And we do have ways of
For
linking.
internal projects in a company, it's a very good advice to put the name of the owner of the concept.
Yeah.
Because it do a lot of helps when you later on, 5 years later, you need to review and to discuss again the meaning of the concept.
Yeah, standards are hard that way because it's always sort of a collective effort. And, you know, it's sort of like, you know, my job is not so much ontologist, is more, you know, cat herder. I just, you know, try to keep cats kind of going in the same direction. That's success. So, yeah, no, I get what you mean. It's very, you know, standards are kind of their own weird set of animals.
When you have the language ready, let me know, please.
Yeah, sure.
I am in the door waiting for this.
Thanks.
Phone is off.
Is there any more question? Yes. Go ahead.
So maybe I need more information about 2 points that you mentioned. First one is the ontology development tools. You said that you got funding from NIST.
Mhm.
So if you can provide more information on that. And also for the ontology portal, because we are creating one in AutoCommons. So I would like to get more information about what is your plans.
Yeah, so I mean, a lot of that I have to actually punt to some of the people at ADM Council to go through some of the details. Some of that's still being worked out, but again, a lot of the tooling is around. The first piece is a serialization. So it's a serializer that pretty much takes either, you know, Turtle or Owl, you know, RDF XML or, you know, Owl XML, and parses it and then generates canonical RDF XML by reformatting it and normalizing it to like reordering the various different definitions and annotations and such so that you can diff it. Because Prodigy and other tools tend to kind of, you know, make a mess out of whatever you put into them. So that's one piece of it. That's kind of like the first piece to even get your repositories in shape so that when somebody's doing a review and they see what changed in this edit, they don't have to, scroll through thousands of lines of XML and just kind of just throw their hands up and say it's pointless. So that's one piece that's going to be one of the first deliverables. The other pieces are the CI/CD tools, which do all the SPARQL queries and validation, so logical consistency validations using one or more, at least Palette and possibly, one of the other reasoners as well, just to make sure that we have reasonable coverage. And then to run a set of SPARQL queries with some test data to make sure that the optimization is doing what we want it to do. So those pieces are part of that automated test process. So that's going to be part of this framework as well. And the portal piece, that you definitely have to talk to EDM Council, because that's something that they've done for 5.0 and will be brought into this project as well, that framework for being able to navigate. So, I talked to Ark a little bit about this today, that we really need to talk to you guys, because you seem to be going down the same path.
Yes, actually, I was thinking to make this comment, we can actually benefit from each other. So the industry portal is very rich in the FAIR metadata. So we integrated something called emoji 1.4, which has like 64 annotation to make it really fair. And then you can also test it, how fair it is and stuff like that. However, the CI/CD tool, as you were saying, is not integrated within that portal that much. So I think that we should collaborate, join hand, and then bring the CI/CD and all the shaker, tester, parser in the submission process of the industry portal. And then you can also have all this fair annotation and metadata. And then definitely I'm for sure looking forward to a conversation with Elisa and you about that, yes.
Yeah, well, let's get that going, because my general philosophy around standards is laziness. So, if somebody else is doing something, let's work on it together so we don't do it twice. There's no reason when you're doing open projects around standards to repeat effort.
Yes, and also, it should not be an ontology portal proliferation, which ontology proliferation is already bad enough.
Yeah, you just confuse people.
Yeah, also, in terms of tools that we see the demo with Dimitris this afternoon from Total, that's an open source tool that they are developing, and I think it's impressive, especially from a visualization point of view. So they have session tomorrow to make a demo tomorrow morning, and I think we can build a lot of things around this tool, especially that it's open source.
That'd be great.
And so I think we'll have more discussion on tools tomorrow.
That'd be great. Yeah, one of the things that I think, we keep talking about within, like in IOF is the lack of really good open source tool ecosystem around ontological development. I think it's stifling us, where you see, you still look longingly at the machine learning guys with Jupyter notebooks and RStudio and things like that. They have all these tools and cool technology that all the cool kids can use, and we got Prodigy. It's like, yeah, I don't feel that cool.
If you have it open source, who pays the bill of developing and maintenance of the tools?
Well, that's where the community's got to step up. If industry and the community value ontological development and they value ontological standards, then maybe somebody should help out. Somebody's helping out with RStudio. That ain't free to build. There's tons of plugins and learning models in that thing. Same thing with Jupyter. Python. That whole community is. So I find a huge amount of work going on there. So somebody's got to be footing that bill. So you figure, if there's value here, then we should figure out how to, move the ball forward.
Perfect. Thank you.
Yep.
Thank you again.
Sure.
Okay, so as usual, the driver is waiting, you're late. So for this, for this evening, for the dinner, maybe, suggest to meet in Verdun. So it's up to you to go. There is a lot of restaurants there. There is L'Europe, there is Chez Marcel. So there is a lot of restaurants on Verdun Square. So if you want to meet there, so that's maybe a possible thing. Not very good news for people who will visit the picnic. So they called us and they announced very bad weather tomorrow. So unfortunately, for 90% it will be cancelled. So we have a plan B for the social event. So, but we'll confirm tomorrow morning. And then for tomorrow morning, the bus is 8:30. And also the morning session will be in Outfield B. So Alessandro Nave will be in the other building. So just all. Thank you very much and see you tomorrow.
Un peu tard, et there's nothing. I would suggest people